The alkyl halides can be used to prepare organometallic compounds. Organometallic compounds are compounds that have a carbon that is bound to a metal. Organometallic compounds are unique because the metal, with its low electronegativity, gives a large del negative on the carbon. That makes the carbon very nucleophilic. We're used to carbons being electrophilic. Now, with this kind of bond, we get a nucleophilic carbon. There are 3 metals that we'll look at in this chapter. One of them is magnesium, and it gives a Grignard reagent, which is shown here. It's an alkyl group attached to a magnesium, which is then attached to a bromide. There's the alkyl lithium compounds, which are just alkyl compounds directly attached to a lithium. And then we have what are called Gilman reagents. And the Gilman reagents are those in which you have 2 alkyl groups attached to a carbon, which then has a lithium attached to it. The carbon with a large del negative on it is nucleophilic, but it's really important to remember it's also very basic. Anytime you have an organometallic compound, at least of these organometallic compounds, and you have something protic with it, what is something protic? Something with a hydrogen attached to an oxygen or with a hydrogen attached to a nitrogen. Anything that is protic is going to act as an acid, and the organometallic compound will do an acid-base reaction with it, taking the proton off of this and making the salt out of the oxygen or nitrogen. Okay, to form the Grignard reagent, what you do is you take an alkyl halide and you mix it with magnesium in either ether or tetrahydrofuran. The use of these solvents is essential because it actually helps participate in the reaction that forms the Grignard reagent, so we almost always include them in the reaction, in our reaction conditions. This is a very interesting reaction because the metal actually inserts itself between the carbon and the halogen, and it ends up giving this Grignard reagent here. Any of our compounds can do this. We often will be telling you, oh, well, we can't use carbons that are sp2 for various reactions, but with the Grignard reagent, if you have a halogen on a carbon, it will do this reaction. It will do the insertion reaction, and you will end up getting the Grignard reagent. So it can be attached to primary, secondary, tertiary. It can be attached to a vinyl carbon. It can be attached to a benzene carbon. The Grignards will react with a protic hydrogen. So let's look at an example. This is a strong base. Here is an acid. That strong base is going to pluck a proton off of the acid. What do we get as a result? We get the alkane and the magnesium bromide hydroxide. Protic hydrogens are all going to be acidic enough to react with the Grignard reagent. What are the protic hydrogens? Protic hydrogens are those that are attached to an oxygen or a nitrogen. Here are some examples: alcohols, amines, carboxylic acids, and amides. So you go ahead and look at this reaction here. Here we're going to take the magnesium and we're going to mix it. There's that THF that's required for the reaction. We're going to mix it with this halide. When I mix it with this halide, the magnesium goes ahead and inserts into this bond, but the moment that it forms, boom, it's going to react with this alcohol group, and it deprotonates the alcohol group, and it makes a salt right here, and that hydrogen then ends up getting stuck where the bromine was. This slowly forms up here, but acid-base reactions or proton transfer reactions, whatever you want to call them, are exceedingly fast compared to other reactions. Here's a couple you try it's for you. How would you form cyclopropyl magnesium chloride? Well, cyclopropyl magnesium chloride is going to be a cyclopropane in which one of the carbons is bound to a magnesium and then the magnesium to a chloride. So let's look at this. This is the product that we want, the cyclopropyl magnesium chloride. All we have to do is think back to what do we need. You take the magnesium out, and then what you get is cyclopropyl chloride. Of course, we also have to have magnesium and THF or magnesium and ether. What is a Grignard reagent formed from butyl bromide and magnesium in ether? Well, if we look at butyl bromide, that's going to be a 4-carbon chain with a bromide attached. And then we use magnesium and ether, and we form the Grignard reagent shown right here. The Gilman reagents are formed in 2 steps. The first thing you have to do is form the alkyl lithium compounds. To form the alkyl lithium compounds, what we have to do is take an alkyl halide and react it with 2 lithiums. Why do we have to have 2 lithiums? Because 1 lithium is needed to form the lithium halide, and the other lithium is needed to form the alkyl lithium compound. Here's an example down here. This is 1-bromobutane. You react it with 2 lithiums, and what do we get? We get butyl lithium and lithium bromide. 2 alkyl lithiums are then reacted with copper iodide to give a dialkyl copper lithium compound. Here is 2 methyl lithiums and copper iodide. You mix them together, and then you get the dialkyl copper lithium compound. This is your Gilman reagent. And of course, one of those lithiums ends up as lithium iodide. We're not too interested in these things over here. What we're really interested in is the organic portions. We can use a butyl lithium in various reagents, and we can use the Gilman reagent in various reactions. This is very basic, and you mix it with anything protic, and it will do an acid-base reaction. These are a little less basic, but they're still basic. The special thing about Gilman reagents is they're considered to be coupling reagents. So if I take a Gilman reagent and I mix it with an alkyl halide, they actually just end up getting stuck together, and that's why we call them coupling agents. Here's an example of it acting as a coupling agent. Here is an alkyl halide, and there's the Gilman reagent. You react them together, and the alkyl group on the Gilman reagent ends up attached to the alkyl group on the alkyl halide. So here we go. This is an alkyl halide, and here is my Gilman reagent. I mix them together, and the iodine is replaced by one of these alkyl groups. Notice it just gets stuck on right there. And so this is a really neat way to increase the size of your molecule with little change to your functional groups. Here's an example of iodobenzene. This is my alkyl halide being mixed with the Grignard reagent, and the methyl group just gets coupled onto the carbon right here, and we get toluene. So now you try to figure out what are going to be the products of these reactions. Benzyl chloride and 2 lithiums. When I mix benzyl chloride with 2 lithiums, what do I get? I get an alkyl lithium compound. Here's benzyl chloride. There's the 2 lithiums. What do I get? Benzyl lithium. You won't be required to know nomenclature of benzyl chloride. That's not going to be tested. What I will be expecting is if I give you benzyl chloride structure and 2 lithiums, that you would be able to draw the lithium compound as a product. What about 2 benzyl lithium and copper 1 bromide? What would form from that? Well, if I look at this, these are the conditions to form a Gilman reagent. So here is the 2 alkyl lithium and copper iodide. I'm going to mix those together, and I end up getting the Gilman reagent over here. Dibenzyl copper lithium with butyl chloride. Here is the dibenzyl copper lithium, and I'm going to mix it with butyl chloride. This is going to be a coupling reaction. One of these alkyl groups on the Gilman reagent is going to get it, basically push the chloride out of the way and become attached there. So you just stick them together. What about isopropyl bromide and magnesium? This is isopropyl bromide, and here's the magnesium. Of course, you have to have it in THF for this to work, but what do we get? We end up getting the Gilman reagent. What reagents are needed to form the following organic compounds, organometallic compounds? Methyl magnesium iodide. To form methyl magnesium iodide, you would have to have methyl iodide mixed with magnesium. Cyclopropyl lithium. To form cyclopropyl lithium, I'd have to have something like cyclopropyl chloride or cyclopropyl bromide and 2 lithiums. And here we go. There's cyclopropyl chloride with 2 lithiums. What about phenyl magnesium bromide? Well, that's a Grignard reagent. To form that, I'd have to have phenyl bromide and magnesium in either THF or ether. Here's the phenyl bromide and magnesium and THF. I mix them together, and I end up making the Grignard reagent. Ethynyl magnesium chloride. Well, you probably don't know what ethynyl means, but that's going to be 2 carbons with a double bond on it, magnesium chloride. So I'm going to have 2 carbons with the double bond and a chlorine attached right there. And then I mix it with magnesium ether, and it gives me the ethynyl or vinyl magnesium chloride.